So the next one is the electric potential energy of 2-point charges is dash. Okay. So now we are going for electric potential energy. Okay. So what is electric potential or electrostatic potential energy or electric potential energy? So amount of work done to assemble charges. Okay. The work done equal to V into Q. Okay. So we know that for V is the potential. 1 by 4 pi epsilon 0 Q by R. Now we can substitute then the work done which is saved as energy. That energy is electrostatic potential energy. Okay. 1 by 4 pi epsilon 0 Q by R into Q. So far we have studied 4 cases: force, electric field, electric potential, and electrostatic potential energy. So how we can remember the formula? For force, 2Q, 2R. So why we are saying like this? The force is directly proportional to product of the charges and inversely proportional to square of the distance between them. Okay. Next one, the electric field. Directly proportional to 1Q and inversely proportional to 2R. Okay, Q by R squared for electric field. The third one is potential. Directly proportional to 1Q and inversely proportional to 1R. Okay, the last one is electrostatic potential energy. 2Q and 1R. Okay, so 2Q and 1R is the electrostatic potential energy. Okay, now I am trying to assemble 3 charges on the vertices of that triangle. It may be equilateral triangle or right angle triangle or isosceles, whatever it may be, the formula will be same. So the 3 charges Q1, Q2 and Q3 are placed at the corners. Okay, are vertices of the triangle. Now the distance between these two R12, here R23, here R31. So to assemble these 2 charges, the epsilon equal to 1 by 4 pi epsilon 0 Q1 Q2 by R12, then it can be taken as epsilon 1. So to assemble these 2, epsilon 2 equal to 1 by 4 pi epsilon 0 Q2 Q3 by R23. To assemble these 2 charges, the epsilon 3 equal to 1 by 4 pi epsilon 0 Q3 Q1 by R31. Okay, so now we can add. So epsilon 1 plus epsilon 2 plus epsilon 3 equal to the 1 by 4 pi epsilon 0 can be taken as common. Okay, so Q1 Q2 by R12 plus Q2 Q3 by R23 plus Q3 Q1 by R31. So this is the electrostatic potential energy due to system of charges. Okay. So the same question may be asked. When the uniform electric field, in an uniform electric field, when we are placing an electric dipole minus Q and plus Q, then it experiences rotational effect. Then work done equal to tau into theta. Work done equal to tau. So far we may be confused by work done. So in general we can go for work done equal to force into displacement. Then work done equal to here potential into charge. Now the work done equal to tau into theta. The work done is saved as energy, that is electrostatic potential energy. Then finally we can get minus PE cos theta. So we can go for the first word when it is aligned. Or when it is kept parallel. Then theta equal to 0. So 0 into cos 0 equal to 1. So 1 into something. So minus PE. Here we are having minus. So electrostatic potential energy is minimum. Electrostatic potential energy is minimum. Next one, when it is kept perpendicular or when it is kept normal. When it is kept normal, so theta equal to 90. Cos 90 is 0. So 0 into something, 0. So electrostatic potential energy is 0. Then we can go for third case when it is kept anti-parallel. Anti-parallel, then theta equal to 180, then cos 180 equal to minus 1. So minus 1 into minus PE, so epsilon equal to plus PE. So whenever the electric dipole is placed anti-parallel or aligned opposite, then its energy is maximum. Its energy is maximum. Okay. So by taking cos, we can write epsilon equal to minus P vector dot E vector. So dot product of two vector is a scalar. Dot product of two vector is a scalar. Okay. Now the P vector equal to I cap plus 2j cap plus 3k cap. Then E vector equal to 2i cap plus 4j cap plus 3k cap. So what is electrostatic potential energy? So the electrostatic potential energy equal to minus P vector dot E vector. Okay. So minus of P I cap plus 2j cap plus 3k cap dot 2i cap plus 4j cap plus 3k cap. Okay. So I cap minus of. So 1 into 2. 2 fours are 8 plus 3 threes are 9. So 8 plus 2, 10, 10 plus 9, 19. So minus 19. So we calculated the electrostatic potential energy. The unit of energy is joule. So 19 joule is the electrostatic potential energy. So here we can go for I cap dot I cap, J cap dot J cap, K cap dot K cap equal to 1. So that is the principle of dot product of two vectors. Do you get it now? Do you have any doubts? Okay, thank you.